talk about interconnection of systems. I mean how the systems are connected. Very often we are interested in finding out the response of a system under the influence of a particular input. We are not so much bothered about the what is happening in the inside the system. Let's say this is my system. I give input and I am waiting for the output, expecting the output, and we least bothered what is happening inside the system. Okay, how the internal what is happening internal to the system. Okay, so in this event we represent a system as a block box. It is BLACK box or BLOCK box. I think BLACK box, black box, and the various inputs. Okay, so you can, it may contains not only one input, it may have many inputs. Not necessarily that it should have only one input. Let's say x1, x2, x3, and right up to xn. So I have n number of inputs. Let me call m. So m number of inputs. To the system. And under the influence of these m number of inputs, there are certain responses that I can expect from the system. Okay, so these are the outputs which we are interested in. Let me call y1, y2, y3, and up to yn, right up to yn. Okay, this y1 to yn are called responses of a system, or you can call output of a system. Outputs, because there are many outputs. Similarly, these are called inputs. Sometimes people will also call excitations. So the system responds under the influence of an excitation or under the influence of excitations. Therefore, the system gives an output under the influence of an input, and there may be n such responses like y1, y2 up to yn we are interested in. So in this particular case, particular system, we will possibly have m inputs and n outputs, and then the representation like this is referred to as multiple input, multiple output systems, because I have more than one input and more than one output. Such systems are called multiple input and multiple output systems. So you take this first letter, put m, and here you take this first letter, put I, again here also take first letter, and here also take first letter, m and o. Then finally mi, mo, multiple input, multiple output systems. So in short form, this is called MIMO systems. Okay, now let us consider an electrical network where you have several sources, voltages and currents, and there are various inputs to the electrical networks. Okay, so we are interested in finding out the, let me say, V1, voltage 1, V2 up to Vm. So I am giving many inputs as a voltages, and I am interested in to find out what is the corresponding. Let me VO1, VO2 up to VON. So this is my electrical system, or I can say system or network, it's not an issue. When I say network, then it is more appropriate to call it, because you are connecting similar type of components. So that's why we always say electrical networks than electrical system. System means it comprises of many components which are not of the same type. For example, if you take an automobile system, there you have mechanical inputs, mechanical outputs, electrical input and electrical outputs. So you have not only mechanical device, but also you have electrical device. So collectively you call that as system. But if a thing which consists it contains only similar type of components, then you better call it networks. Sometimes, very often, we might be interested in finding out the influence of one particular input. I don't have many inputs. I have only one input. Let me call X1. And I would like to find out the response at a particular location or due to that particular input signal. So let me call that response y of t and the input is x of t, and this is my system. Now I have only one input and only one output. So this system is called a single input, single output system. So I take the first letter S, here you take the first letter I, here you take the first letter S, and here you take the first letter O. So this is called a SISO system. Okay, so this will be called a single input, single output system. But the class of systems which we will talk about in this lecture, which comes under the category of linear time invariant systems. Okay, so if you have a complete knowledge of how a system behaves with a single input and a particular output, then we can use that information to get a particular response when a variety of inputs occur simultaneously by the principle something called superposition. Okay, so the superposition is something which we can always do for the particular class of systems, okay, that we are talking about. So our concentration may be for most of the time on single input and single output systems, at least in this course. Probably you may be studying this MIMO systems in some other context, especially in wireless communications and in antennas and wave propagation. There we will talk about MIMO antennas, and in your mobile phone we will see MIMO, multiple input multiple output transmissions, and SDM, spatial division multiplexing. There are many things, okay, but in this course mostly 99% of the time, or you can say 100% of the time, we will be talking about SISO systems. So as I mentioned, this system represents for me as a block box. I don't worry what is there inside. I will only worry about what is my output for a given input x of t. Once if I know the relation between y of t and x of t, then I can study about the system. Okay, so therefore we can assume that this has two terminals where the input is fed, because for any electrical input you need at least two terminals. Without two terminals you cannot feed any signal. Okay, one is plus and another one is negative if it is DC. If it is AC, then phase and neutral. So without two terminals you cannot, even if you take light or fan or whatever the device you take, you need two wires. Therefore the input is denoted by a pair of wires. Similarly, the output is denoted by another pair of wires. Because in electrical systems we always talk about voltages and currents. So for this voltages and currents I need at least two wires. And the system has two terminals where the output is taken out. Okay, so and this whole concept of a particular input giving rise to an output can also be, as I said, very succinctly and compactly indicated as x of t gives rise to y of t, and this is succinct form of notation or compact, succinct or compact way of writing input and output relation of a system. Relationship of a system. That means in the particular system, once we know what the system is, then we can say the system input is x of t gives rise to an output y of t. So very often we use this notation, x of t gives rise to y of t. This is a succinct notation. Okay, so very often we use this type of arrow mark notation when we have to deal with a particular system, and we would like to have a variety of compact of inputs, and what are the outputs that you get. We use this kind of representation. Okay, so as I said, the systems are interconnected, many systems. Okay, in general you may not have only one system. Sometimes you may have more than one systems. In that case we need to connect one system with the other system. So that's why next we would like to study about interconnection of system, how we can connect one system with the other. Interconnection of system. So this is an important idea, okay, that we will use this interconnecting concept throughout this course. In fact, many real systems are built as interconnection of several subsystems. If you take a general overall system, and this system contains several subsystems, subsystem 1, subsystem 2, and so on up to subsystem capital N. So the overall system contains many subsystems. For example, if you take an audio system, okay, which involves the interconnection of your radio receiver. Your radio receiver is an antenna. The antenna receives a signal, and it gives to compact disc player and or tape deck with an amplifier and one or more speakers. Okay, you have radio receivers, and this one is given to this is something called super heterodyne receivers. Okay, when you come to the higher semester you will be studying about this. Again you will be having some mixers, then followed by some filters, then you will be having amplifiers, especially power amplifiers, then it is finally given to the speaker. See, it has many components. Even for mixers, you put one more system here, something called local oscillators. In the same system, you can put a CD player also, or cassette tape deck also with an amplifier, and those two are connected to power amplifiers. Cassette player here. These two are connected to the power amplifiers, and the power amplifier output is given to the speaker. So these are some typical examples of a system where the system contains many subsystems. So you can give like this many examples, like a digitally controlled aircraft, which is an interconnection of the aircraft, okay, described by its equations of motion and the aerodynamic forces which affects it. Like in the aircraft, you may have the sensors which measure the various aircraft variables. Okay, there are many sensors, especially electronic sensors, which are used to measure the accelerations, rotation rates, and heading. Okay, a digital autopilot which responds to the measured variables and to command inputs from the pilot. And nowadays, the aircraft is completely automated, so the pilot is simply sitting and watching and monitoring, that's all. So rest of the things that digital autopilot will take care of. It decide altitude, speed, and everything. Okay, so it also controls the aircraft's actuators, and which respond to inputs provided by autopilot in order to use the aircraft control surfaces, like it controls rudder, tail, and ailerons to change the aerodynamic forces of an aircraft. So therefore, in overall, we can view a system as an interconnection of its components, many subsystems. We can use our understanding of the component of systems and how they are connected, interconnected, in order to analyze the operation that we want. So there are three ways basically you can interconnect the system. The first one is series connection, also called cascade. Don't confuse, there is one more word called cascode. C-A-S, let me write C-A-S-C-O-D, cascode. Cascode is different from cascade. These two words we generally use in communication engineering. See, we have cascade amplifier. Probably you will be studying this in your electronic circuits or electronic devices. And also we have cascode amplifiers. So don't confuse. This cascode is completely different from cascade. Cascade means one after another. That means series. Okay, so one can construct a variety of system interconnections, and the first one is a series connection or a cascade connection of two systems. That means you take one system, subsystem, let's say system 1, and the system 1 output is given to the input of system 2. So this is my x1 of t, output is y1 of t, and the input of second subsystem 2 is x2 of t, and the output is y2 of t. Therefore, x1 of t gives rise to y1 of t, and x2 of t gives rise to y2 of t. Now you can replace this guy because x2 of t is equal to y1 of t. Therefore, y1 of t gives rise to y2 of t. Okay, so diagrams such as this are referred to as block diagrams. Okay, so here the output of system 1 is the input to system 2, and the overall system transforms an input by processing it first by system 1. See, the input is x1 of t, and that is first processed by system 1, and then you allow the system 2 to process it. Okay, an example of a series of a series interconnection is a radio receiver followed by an amplifier. You look at here, I already given is, so antenna followed by radio receiver, and then mixer, and mixer followed by filters, and then amplifiers. These all are series connection, interconnection. And then let us talk about parallel interconnection. Okay, it not necessarily should have only two systems like this. You can have n number of systems like this in series. Of course, it has its own pros and cons that anyway we will not discuss now, but you can have n number of systems in series. Okay, the next one is parallel. So a parallel interconnection of two systems is as follows. System 1, system 2. The input is common to both the system. Same input is given to both the guys, and the output is, you just sum them up and get it output. Okay, and here this plus symbol in the figure denotes addition of two outputs. So this is y1 of t, and this output is y2 of t. You put an arrow mark like this, and here also x1 of t, and here also x2 of t. Now if you want to denote this in succinct form, then x1 of t gives rise to y1 of t. Again the same x1 of t gives rise to y2 of t. Okay, an example of a parallel interconnection is a simple audio system, okay, with several microphones feeding into a single amplifier or speaker system. Like you take several microphones, and this all microphones feeding into a single amplifier or a speaker system. Okay, so in addition to this parallel and serial interconnection, we may have both series as well as parallel. Okay, in one arm it may have series connections, and other arm it may have parallel connections. And similarly, we can define one more point I forgot to tell you here. It not necessarily can have only two systems. I can have many systems in parallel, like this 1 2 3, sorry, this is n. So the same common input is given to all the systems, and finally put an adder here. By the way, one important point is you cannot add more than two signals by an adder. Each adder can add only two signals. That is the constraint. Generally people what they will do is you cannot put like this. You cannot take, this is my y of t and this is all y1 of t, y2 of t, y3 of t, y4 of t, and y5 of t. Like this if you write, then this is wrong. Don't write like this. You take an adder, it can add only two signals at a time. Sometimes you may have complex version, like you have system 1, then in series with system 2, again system 3, in parallel with one more system 4, like this. So it's a complex connection, x1 of t. Like this also you can have it. And the next type is something called a feedback interconnection. A portion of the output is fed back to the input. So you have input, and that input is given to a system 1, and this is my output. Let me call y1 of t, and this y1 of t, a portion of the y1 of t, not completely, a portion, a little portion, is fed back to the system 2. The output of the system 2, let me call y2 of t, and this is x2 of t. Input to the system 2 is x2 of t, and this is fed back to the input to the first system. This is your x1 of t. So this is called a feedback interconnection. You are taking something from the output, and you are feeding the system 1 through system 2. Okay, so here what you are doing, the output of system 1 is the input to system 2. Okay, while the output of system 2 is fed back and added to the external input. This is my external input. If you look at the whole as like this is my system, overall system. So this one is internal input, feedback input, internal feedback input. These feedback systems arise in a wide variety of applications. For example, again, a cruise control system on an automobile sense. Okay, automobile senses the vehicle's velocity. So based on the vehicle velocity, it adjusts the fuel flow in order to keep the speed at the desired level. Suppose if the velocity is more, then you have to inject more amount of fuel. So you are taking the feedback from the machine. Similarly, a digitally controlled aircraft is most naturally thought of as a feedback system, in which differences between actual and desired speed, and in which direction it is heading, and what is the altitude of the aircraft. These all are fed back through the autopilot in order to correct these discrepancies. If there is any discrepancy, then these all are corrected. Also, in electrical circuits also we have this feedback. In fact, you will be studying in detail in your electronic circuits, like positive feedback and negative feedback. This positive feedback is very bad actually. So not only this positive feedback is very bad for circuits, in fact for human being also this feedback is very bad. So whenever you get negative feedback, then there is a chance to improve yourself. Okay, whoever is criticize you, you always welcome them. Okay, whoever is praising you, don't allow them near to you. That is not good for you. So in electronic circuits, we always 95% of the time we use negative feedback. Remaining in fact, it doesn't mean that the positive feedback is completely bad. It is good, but this is used in oscillators. So whenever you want to generate oscillations like a sine wave like this, or a triangular wave like this, or a square wave like this, then we use positive feedback. Maybe I will take one more example. So I will not go into details of this circuit because it is not relevant to our course. Anyway, just for the completeness I am giving you. In parallel you have a capacitor. The current flowing through the capacitor is I of t. Then you have another parallel arm. It has a resistor. Its value is R. Current flowing through this guy is, let's say, I suffix 2 of t, and this one is I1 of t. Now you wanted to know what is the voltage at this point, V of t, and this is positive and this is negative, and your current is flowing in the upward direction. Okay, and these electrical circuits are often viewed as a feedback viewed as a containing feedback interconnections. Okay, like this can be transformed into block diagram, like the input is I of t, that is given to a system. The first system is capacitor. Okay, so capacitor, the voltage across the capacitor is equal to 1 by C integral of I1 of t I1 of t times dt, like this. Then the output is voltage, what you want. The portion of the output voltage is fed back through a device resistor, and here I2 of t is equal to V of t over R. This is my feedback system, and then it is added to the I of t with polarity negative here, and this is positive, so it is a negative feedback system. If it is for positive feedback, then it will become an oscillator. And this is input and this is output, like that. That's it. Okay, simple electrical circuit, and in that we have given the block diagram in which the circuit is depicted as the feedback interconnection of two circuit elements. So I think we come to an end, so let me stop at this point. In the next lecture, let me talk about various properties of system. Thank you very much.